when we're thinking about the graph of a polynomial, all the important information happens within the first term and the last term. The first term gives us a lot of information. First of all, the number of terms has to do with the degree of the polynomial, the largest power. And since this is a third degree polynomial, the number of turns that its graph will have is at most 2. So the number of turns is always 1 less than the degree. When it comes to the end behavior is always describing what's happening on the right side of the graph. And how we're going to describe this is we're going to say as x approaches infinity. That means as the x coordinates get larger and larger and larger, I want to know what happens to the y coordinates. And in this case, since the leading coefficient 4 is positive, that means that the graph is going to go up, making its y coordinates approach positive infinity. This is enough information to help us come up with a sketch of the graph. So since as we go to the right, the graph is going to go up, we just start with that. Then, since I know that there's going to be 2 turns, here draw in the first turn, and then draw in the second turn. That means that the graph of y equals 4x to the third minus 5x squared plus 7x has to look something like this. Now where it is on the coordinate system, not really sure. All I want to know is just its general shape. Now the last piece of information, that constant term that's at the end, this is going to be the y-intercept. And that's because if we're going to try and find a y-intercept, we're going to try and calculate it, the way we have to do that is to let x equal 0. So if we go to this equation and substitute 0 every place that we find x, the only term that doesn't have an x in it is that constant term. So y is going to equal 0 minus 0 plus 7, which is 7, making 7 the y-intercept.